This chapter will give you an overview about what is system software and why it is needed. This unit will help you to understand what operating systems do and why it is needed. A computer without software is like an empty shell and is dead. With software, it becomes alive. There are basically two types of software: system software and application software. Application software is used to perform specific tasks like browsing the web. Application software will be dealt with in more details in Chapter 7. System software, on the other hand, is responsible for administering the computer. It is the software that starts the computer and presents a nice interface, allowing humans to work with it. Examples of system software are operating systems like Microsoft Windows XP and Linux. System software. System software can be considered as being a layer between the hardware and applications programs. To be able to use a computer, we need software, and a computer without any software is like an empty shell and is totally useless. System software is required to start the computer and do general household jobs like copying files, renaming files, providing access to the networks, and provide service to application software. Without the system software, the computer doesn't work. System software is a very generic term, and under its umbrella, it regroups many different types of software. They all have their different specificities and will be responsible for different operations in the computer. The different software are: operating system, which is the main part of system software; BIOS, drivers, utilities, and service programs; compilers, translators, and database management systems. We will elaborate more on the different types of software in the next section. Operating system. The operating system is the most important component of the system software. The operating system acts as a host for applications that are run on the machine. As a host, one of its purposes is to handle the details of the operation of the hardware. This relieves application programs from having to manage these details and makes it easier to write applications. The figure shown here is a layer structure, illustrating where the operating system is located on generally used software systems on desktops. All applications have to talk at some point, and operating system needs to be present on all PCs. Two examples of commonly used operating systems are Windows XP and Linux. They are built differently, look different, but do the same thing, and provide a nice interface to users and allow easy interaction between application programs and the hardware. Components of the operating system. The operating system is made up of several small parts, but they are packaged together when delivered to customers. These components are kernel, graphical user interface, and some utility programs. The kernel is the heart and the essential center of the operating system. It is the first part of the operating system that is loaded into main memory and stays there as long as the computer is running. It provides basic services to other parts of the operating system, but is specifically responsible for memory management, task or process management, and disk management. The kernel performs its tasks, such as executing processes and handling interrupts, in kernel space. It is usually loaded into a protected area of memory, which prevents it from being overwritten by other, less frequently used parts of the operating system or by application programs. Graphical user interface, GUI, is the visible part of the operating system. It usually provides a nice interface for the user to interact with the computer. A graphical user interface provides computers graphics capabilities to make the program easier to use, and it frees the user from learning complex command languages. Therefore, interaction will involve clicking on icons to manage files and launch application programs like browsers. However, the operating systems usually comes accompanied by small programs that do some specific tasks. Utility programs help manage, maintain, and control computer resources. These programs are available to help you with the day-to-day tasks associated with personal computing and to keep your system running at peak performance. Most operating systems have a module that manages communication with the network, for example, allowing connection to the internet, simple text editors, and some hard disk maintenance utilities, for instance, the defragmenter. Utility programs include virus scanning software, backup software, ScanDisk, and also disk defragmenter software. Functions of the operating system. The operating system does many things at any time. Typically, more than one program will be running at the same time. For example, an MP3 music file is being played while an antivirus software is running. Yet, the computer has limited resources, that is, fixed amount of memory and CPU, and they must be shared between the different programs running. So, the different tasks an operating system has to do is process management, that is, assignment of processor to different tasks being performed by the computer system. For example, if someone is chatting on the web, listening to music, and scanning his computer for viruses at the same time, so, what happens? The computer will have to share the CPU among the different programs requesting it. To do so, the computer will opt for process management and will work with processes. The operating system tries to share the CPU among the different processes needing it. It uses what is known as scheduling algorithms to decide which process should be allowed to use the CPU and for how long. When there are many programs requesting the CPU, the operating system will allocate a small amount of time to each process and cycle between processes until the process has been executed. Memory management is the allocation of main memory and other storage areas to the system programs as well as user programs and data. Disk management is a term used for a variety of functions, for initializing a hard disk, maintaining its health, and managing its use in an organized way. Input and output management is the coordination and assignment of the different output and input device while one or more programs are being executed. Communication management translates responses from the component computer part back to responses that can be understood by the operating system, application program, or user. Types of operating